This video covers the lab Introduction to Oceanography. I'm assigning activities 1 through 3, 4B, 5B, and the lab report questions, all of them except number 4. It will be really helpful if you watch some of the ocean videos before you do this lab, because it will solidify some of the concepts that are covered in this lab, including salinity of the ocean, density of the ocean, and seafloor features. I'm especially recommending Ocean 7A.1 and 2 and Ocean 7B.1, 2, and 3. There are others, but those are the ones that are related to this lab. The first activity asks you to look at the extent of the oceans around the Earth. Activity 1A simply asks you to put the names of oceans and other major water bodies on this map, pretty straightforward, and then answer a few questions. Activity 1B begins by telling you that the total area of Earth is about 510 million square kilometers. Of this, about 360 million square kilometers are covered by oceans and marginal seas. So they want you to use this information to calculate the percent of Earth's surface that's covered by ocean and marginal seas. And they give you the formula. Take the area of the oceans and seas, which is 360 million square kilometers, divide it by the total area of Earth, 510 million square kilometers, multiply by 100, and you get the percent covered by ocean. Now you can also do it with the million square miles values. Just make sure you use both of those numbers in your equation. They then ask you to do the same thing for the land surface. Question 3 says to refer to figure 1. So remember, figure 1 is over here. And it's asking you which hemisphere would you call the water hemisphere and which one would be the land hemisphere. So remember that the hemispheres are divided by the equator. We have the northern hemisphere here and the southern hemisphere here. So you can look at this maybe and make an estimate, or you could look at some of our past discussions of the Earth and the extent of land and oceans and answer this. Questions 4, 5, and 6 look at this figure right here. So let's blow that up and take a quick look at what's being shown here. This is showing the millions of square kilometers per 5 degrees of latitude of land and then the various oceans. The y-axis is showing latitude. So here's the equator. Here's 30 north, 60 north, and the North Pole. 30 south, 60 south, and the South Pole. So how do we read this? Well, let's take a look at 30 degrees north. At 30 degrees north, there is, if we drop down, somewhere between maybe 75 or 80 million square kilometers of land. In terms of ocean, we drop down where that line intersects this blue pattern, and we find that there's about maybe 115 or 120 million square kilometers of ocean at that latitude. The Indian Ocean does not reach that latitude, but we have the Atlantic and the Pacific involved. The Arctic is also not at 30 degrees north. So that's how you read this chart, and it will help you answer the questions associated with it. The very bottom of this page moves on to activity 2, measuring ocean depths. And there's a term here called bathymetry. Bathymetry is the depth below sea level that the ocean floor is at. So on land, we have something called topography, and that is your height above sea level. How do we figure out the depth to the sea bottom? Well, here is one example right here of something called echo sounding. There's a ship on the top of the sea, and it sends a sound wave down through the water column, and it hits the bottom of the seafloor, and it bounces back. They time how long that takes. They know the speed of sound waves in water, and they can calculate the distance. So remember, this is coming from a familiar formula, speed equals distance over time. But in this case, what they don't know is the distance. So you need to rearrange this equation by multiplying both sides by time, and distance equals speed times time. The equation they use is right there. Ocean depth, which is distance, is, and let's ignore this half for the moment, 1,500 meters per second, that's the speed of sound in water, and the echo travel time, that's the time. Now the reason it has a half is because if you think about it, the time it takes for this wave to go down and back up is really giving you twice the distance that you want, because you're measuring the time for the wave to travel in both directions. So if you take half of that value, then you get the ocean depth. So you're asked to calculate the ocean depth in meters for a couple of these different echo travel times. The next thing you're asked to do is plot the depths given here on this chart over here. And these are the depths of the Atlantic Ocean as you go off the coast from Cape Cod, Massachusetts. So I'm going to blow this up so we can look a little more carefully, and I'm going to help you plot some of these. So the very first point is at 0 kilometers and 0 depth. It's at the beginning of the survey. We have depth in meters here, so sea level, the top is here, and the deepest part of the ocean is here. Along the x-axis, we have distance in kilometers from Cape Cod. So 0, 0 is our first point. Our second point is 180 kilometers from Cape Cod, and the depth is 150 meters. So we come along to about 180 kilometers, that's somewhere along this line here, and then the depth of 150 is very near the surface, so we plot a point there. Point 3 is at 270 kilometers distance and 2,700 meters depth. So 270 is going to be somewhere around here, and then 2,700 meters is going to be around here. So that's point 3. And you don't have to label the points 1, 2, 3. Let's do one more. 420 kilometers and 3,300 meters. So 420 is going to be somewhere close to the 400 because this is the 500 line, right? And then 3,300 is going to be somewhere around here. So that's what you do, and then you're going to wind up connecting all the dots, and you'll have a bathymetric profile of the ocean floor. Under the graph, we have activity 3, which is about the ocean basin bathymetry. Now, they use the word topography here. I'm not sure why they switched to the word topography, but this is essentially bathymetry. There are 3 major units that we divide the ocean into. There is the continental margin, which is the part that's just off the coast and has various features going on underwater. We have the deep ocean basins, which are the parts that are usually far from the coast and very deep, sometimes called abyssal plains. And then we also have a plate boundary called a mid-ocean ridge that can be in the middle of some oceans. It's not shown in this figure here. We haven't talked about geology yet in the class that I'm currently teaching, but that's what this is related to, is a geologic feature related to plate tectonics. If you look through this paragraph, you'll see that there are a lot of words in bold. There's a lot of information packed into this paragraph, so make sure you read through this and understand the definition of all these different terms. The next page shows a map of the Atlantic Ocean, and it asks you to answer about 12 questions related to it. Here's that continental margin portion that's shown right here, and here in the middle is a plate boundary called the Mid-Atlantic Ridge. It's a divergent plate boundary, and the plates on either side are moving apart from each other, as I've shown with the arrows. Activity 4 has an important part to read at the beginning related to ocean salinity and how that changes the density of water and how that drives vertical mixing in the ocean. We're not going to do this first part because this is something that we would have to do in class, but you are going to do activity 4B, which again is a graphing activity. This time you're going to graph the salinity, the saltiness of water at the surface in the Atlantic and the Pacific Oceans. So I've chosen orange for the Atlantic Ocean and green for the Pacific Ocean. You do need to choose 2 colors, and let's just do a few points. So at 60 degrees north latitude, which is shown here, latitude's on the bottom, here's the equator, the salinity in the Atlantic Ocean is 33 per mil. And if you watch one of the videos that talks about salinity, you'll find out what per mil means. In the Pacific Ocean at that same latitude, it's a bit less salty with 31 per mil. At 50 north, the Atlantic Ocean becomes a little saltier at 33.7. The Pacific Ocean also becomes saltier at 32.5. So you're going to plot these points, connect them with lines, and notice trends and patterns that you see in the surface salinities. Questions 6 through 10 have to do with this figure, so let me blow that up and talk about what this is. This is kind of a graph with no numbers. On the y-axis, we have depth below the surface of the sea. It doesn't give you numbers. It's just the relative depth. We've got the surface, some sort of intermediate area, and deep water. Across the top, we're showing salinity. Low salinity at this end and high salinity at this end. Remember, salinity is how much salt is dissolved in the water. We have 3 lines, one showing the salinity changes with depth at the polar latitudes, another one showing the changes with depth at the equator, and the third one showing changes at depth at the subtropics. Notice that at the top of the ocean, the polar latitudes have the least salty water, and the subtropics have the most salty water. There's a transition zone for all of these regions where there's a significant change in the salinity. And then in the deeper water, they all seem to have roughly the same salinity. So that's how you read this graph. Part 5 has, again, a little paragraph that you should read, although we are going to skip 5A and do 5B. Once again, we're going to be looking at a graph after you answer these questions. In this case, we're going to be plotting surface temperature of water and surface density of water. I'm going to use green for the temperature and purple for the density. At 60 degrees north, the temperature is 5 degrees, so we use the scale on the left. At 60 degrees north, the surface density is 1.0258, which is over here, and that's kind of hard to see. You might want to draw a straight line across and then put your point. At 40 north, our temperature has gone up to 13, so we put our point here. And then our density has gone up a tiny, tiny bit to that place right there. So again, you're going to plot your points and connect the dots. This is the last page showing the ones that I've assigned, and basically I've assigned everything except number 4 because that's related to the activities that we skipped. And if you have any problems, again, looking at the videos is going to be very helpful. Good luck.